Hi, everyone, and welcome to our next session. I just wanted to remind everyone that the way you can find this session is if you are on the Glisser platform, there will be the main rooms, and it will always show you which session is currently live. Please find all the sessions there and see which one. And then again, if you scroll down, you'll see the next session always at the bottom of what is coming up next. So with that, thank you, Chris, for joining us today.
Thank you, Vera. Thanks, everybody. This is a lot of fun, streaming virtually, trying to deliver as professional as you can from your own bedroom. Not having to shave is nice, not having to travel is nice, but it would be nice to be able to see everybody. Today, we're going to be talking about some of the things that are happening in performance engineering and its intersection with DevOps. And I'll introduce some of my own stories. My background is I was an engineer for 30 years. Notable was I was at Microsoft from 99 to 2013. And I was part of the development team that created Office 365. Love it or hate it. But it was a lot of lessons learned then. So I've taken all that knowledge and become an analyst. And so I'm here to help you today with not only sort of like, my own background, but actually what I've learned from working with clients and how they're running into performance issues and working with, clients like Neotis and other companies that are trying to, really bring performance engineering into the forefront of a developer's mind when they're thinking about, when I'm writing an application, how do I make sure, how do I plan for performance? Or if I'm taking an application from dev to test to pre-prod to production, what are all those steps? What does it take? And what's going on right now? So first of all, let me just sort of level set and we'll go to the next slide. I've got my own little, definition of digital transformation, right? Transforming the business to be customer focused and deliver value directly to the customer via digital capabilities, right? And I think a lot of companies, which is kind of funny, is before this pandemic hit, and I know we're all sick of talking about it, but I find it kind of funny, right? At Forrester, as an analyst, your job is to try to really convince your clients. There's a sense of urgency. You really need to transform your business because these digital disruptors will come into your marketplace and take over. And they're like, that's never going to happen. We're a grocery store. Who's going to disrupt us? Or we're a healthcare company. We deliver healthcare. Who can't get by without us? Next slide, Vera. What happened is, 2020 is the year digital transformation got real. It smashed people right in the mouth. If you have not been on a journey for digital transformation, if you've not been thinking about how to deliver your products, your services, your APIs, whatever it is your company does, I don't care if it was brick or mortar, if it was something that was like some sort of stodgy system, everyone realizes that this pandemic has opened up the gates that says there's room for digital transformation. There's a need for digital experiences. There are people who don't want to go to the hospital or can't go to the hospital because they're sick or they don't want to get sick. There are people who don't want to go to the supermarket and they're going to go through Instacart. Guess what? That diminishes the brand of that grocery store now because now the brand is Instacart, not the grocery store. So now the grocery stores, your local corner ones, have to think about how do we make sure Instacart comes here? Instacart becomes a partner of theirs. How do they digitally enable their supply chain so that if someone is going to shop on Instacart, they actually know that there's milk on the shelf at the local market basket here up in the Boston area, right? And there's going to be more transformation coming as people start getting used to these apps. This in the top right corner, that's a picture of my garage. My wife and I, we have some family members who are could be impacted severely by COVID. So we've decided to stay away from the gym. We set up our own home gym. There's a little TV. It's hard to see, but that's our trainer. We pay him via Venmo to train us via Zoom, right? And so all of this is happening all at once. Now, sure, everything's going to get back to somewhat normal eventually, but I don't think the lessons learned here are going to be forgotten. I don't think the experiences are going to be lost on senior citizens who realize that, hey, I don't need to go to the grocery store. Somebody can do that for me. Or I don't need to go to the doctor if that doctor has an app. I'll look for an office that has that. Or, I don't need to go to the gym every day. I can just do a lesson online. It worked out pretty well for me. And so that's happening, and it's happening with development teams. It's happening with all kinds of businesses as well, where they're trying to figure out how do we do things remotely. And so what this really gets back to, next slide, Vera, is the age of the customer, right? The fact that software delivery must evolve. And this is what we've been telling people for a long time, but a lot of them were listening, but people weren't listening enough, in my opinion. And the idea is going from customer aware, like, hey, I know I've got customers, what's the big deal, to being customer led, having those customers participate in that customer journey, informing you as to what's important for them from their own perspective about the kinds of features they want. Data rich, sure, you got tons of log files, right? You got tons of data on people. Is anybody using it? Is anybody using it to draw insights? So be insights driven, right? This is why you see AI and machine learning really ramping up, the idea to draw insights out of massive amounts of data. This is becoming a very real thing, trying to figure out patterns, trying to uncover issues, trying to figure out how to further optimize. Insights driven is becoming extremely important these days. Perfect? How many people have been trying to be perfect, right? Let's not release that code until we test every single line of code, and we do every unit test, we do every functional test, and we do it all over again. Well, guess what? Turns out you can't test perfection into a product. It's going to have issues no matter what. Just get it out the door. Do the best you can so that nobody gets hurt. Put that thing out the door and then analyze it. Then use some sort of system of release that allows you to gradually and progressively expose it to more users so you can control the release, but you can go fast, you can learn, and you can continue to iterate. And then siloed. How many organizations work in silos? This is one of the biggest problems that Forrester's clients face, is that they have an IT team, they have a development team, they have a business team, they have a security team, they have a performance team. It's all siloed. And what ends up happening? Everything goes in a serial manner. If you're doing things in a serial manner in that siloed way, guess what? You're doing waterfall, you're not doing agile. You're not really doing DevOps. You have something automated, but it's not DevOps, I'm sorry. What you really want to be is connected. All of those teams connected with your customers, connected with your team, connected with your team of teams. So everybody's on the same page and understands the direction they're going. And so it's really important. This is what we mean by the age of the customer, really letting it drive forward. Next slide, please. And so when Forrester thinks about those four little, little minor things, about being customer-led, insights-driven, fast and connected, we see them coming together into this system that we call the customer-obsessed operating model, right? The customer-obsessed operating model says you need a structure of your organization that can support taking these four main drivers and putting them to work, so silos don't work anymore. You need technology like automation, CI/CD, performance and load testing, security scanning. You need all of these things in the middle of this process, not someplace else, to help drive that forward. You need culture, talent, and metrics, right? These things are all extremely important. They're all necessary to really get truly to that sort of the promise of what DevOps is, the promise of what Agile and DevOps is, and the promise of what a really transformative company can be, to go from just being sort of a bunch of individual contributors to being one team that can really be disruptive versus just sort of, tread water. And so when you think about all those things in this customer obsessed operating model, then you get higher quality apps, you get better business flexibility, you get happier customers. And that's what we're trying to drive home here, right? The idea that there's an aspect of performance that lives in all this. There's performance lives in customer led, performance lives in being insights driven. Performance is part of being fast, and it's part of being connected. So let's go to the next slide, right? Here's an interesting stat. 38% of the business leaders that we've interviewed say that improving the customer experience is a top priority. Now, if you don't know this, Forrester has this this metric, this calculation called the Customer Experience Index. It's a trademarked term. We have these 6 measures that we actually look at. We look at the quality of the customer experience. How effective was the customer experience? Did customers feel like they were getting value from it? How easy was it, right? Was it easy to use this customer experience, or was it complicated to get value out of it? And then the emotion, right? How do customers feel using your experience, right? And you can measure these things not on just software. You can measure it on an infotainment dashboard. You can measure it on a brick and mortar store. I walk into the store and how easy is it to find products? But we're talking about software today. And then customer loyalty. What is the retention? Is your customer experience index so enriching that your customers say, I need to continue using this product? Is it enriching? Are they going to buy other products? Are they going to continue using your service for, all of their healthcare maybe, or all their insurance needs? And advocacy. Do they actually talk about the fact that they had a great experience? So customer experience is really important. The problem is that performance engineering intersects that in almost every single way when it comes to a software experience. So let's go to the next slide. Where does performance engineering intersect customer experience? Almost everywhere, right? Your application performance, the fact that your application might be running on a mobile app, might be running in the web, might be some other kind of, maybe it's an IoT device, whatever. It needs to perform well. It can't have hiccups. It has to flow nice and smoothly. Customers who see a jittery runtime or something that connects and then disconnects or starts spinning, they start losing confidence. Like, I don't know if I want to do banking with this mobile app anymore if it feels like half the time it's not connected to my bank. Or it looks like somebody's hacked my phone because I'm using this app and it's not working very well, right? So application performance is really important. The problem is that application performance is oftentimes reliant and dependent upon application service performance, right? How quick are those APIs getting to that mobile app? How quick is that web app able to download all the images from the CDN? Those are all really important things. If you're not taking that into perspective and you're not measuring that against what your ideal is, or what your necessary ideal is, then your applications are going to suffer. It doesn't matter how well those applications are written. It does mean your applications should be written to be resilient and maybe tolerant of intermediate connections and whatnot, and continue to provide confidence to the user that even though you're maybe walked out of a cell zone for a second, or you're in an airport and you can't get a connection, that maybe it's still working for you, but can tell you what's going on. But those APIs are important. And then as you go down the stack, right? Application services, maybe there's a transaction processing piece, maybe there's a data processing piece. And then at the very bottom, maybe you're connecting to a supply chain. The great example of this is like if you're using like an Amazon shopping app on your phone, it's talking to an application services system, which is talking to some transaction processing system, which is eventually talking to some supply chain system that says, you can get this item tomorrow because we have it in our local Amazon Prime warehouse. That's really amazing. And the fact that you can get that on your phone means that every single layer has to perform exactly right to get you what they want, because they can't cache the knowledge of every single product in that warehouse in your mobile app. That would take too much. It actually is a real-time connection when you go all the way up and down that stack that says, hey, Chris is buying a 100-watt solar panel and it's in stock, he's going to get it tomorrow. That's quite amazing. And so that requires performance engineering. That requires performance engineering at every single layer to make sure that the customer experience is what the customer expects. And because I get that kind of experience from Amazon, I don't usually shop anywhere else. Sorry, Walmart, sorry, everybody else. So now, here's a very interesting thing, right? How does performance engineering intersect revenue? How does customer experience intersect revenue? Well, I already told you about the customer experience index. Forrester has actually tied customer experience index with increased revenue, and we can actually provide a dollar value to every improvement in the customer experience, how it relates to your revenue. And we can do it across, several dozen different industries, whether it's automotive or whether it's over-the-top providers or television providers or cable providers or internet providers. We have it for that. This is an example of that, only at a very fine-tuned and locally scoped spot. Mobify has determined that every 100 millisecond decrease in home page load speed contributed to nearly $380,000 in increased annual revenue, right? How many performance engineers does that pay for in 1 year, right? At least 2 in this economy. And so, the idea that if you can just shrink that time down and make more money. I'm sure there's an area of diminishing returns here, but it just goes to show you that increasing your performance engineering, increasing the performance of your application creates happier customers, allows them to complete transactions on time, allows them to get that order in when they want it to, and increases the revenue for this particular case for this company. The opposite's probably true as well, right? The corollary, right? Where every 100 millisecond increase in page load time probably decreases their revenue. Next page, please. So what are the implications of poor performances on enterprises? Slow applications bring unhappy customers, right? You're just waiting and waiting and waiting. Then you realize, oh, like I did the other day, I was trying to figure out why Spotify wasn't playing on my phone. It turned out it was playing on some device in the living room that I didn't realize it connected to, but that's my fault. Poor scaling results in higher costs to operate. Hey, it's the pandemic. I figure we might as well talk about all our problems, right? If you can't scale, as you get more customers, you run into issues. This is a big problem from Black Friday, right? Where suddenly you have all these sales that are unleashed onto the public and everyone's trying to buy stuff. And if you can't actually close the deal, if you can't actually execute transactions or get your web page in front of people or your mobile app running, you're going to lose money. I don't know what's going to happen this year for Black Friday, but it certainly does impact you when you have to scale up and scale down. Less resilience causes less revenue, less confidence, and potential legal issues, right? This is the other day I was trying to log into Office 365. I told you I worked on that project. I worked on that product rather. This is the screen I got. We're having issues. Great, thanks. You're keeping my legacy alive. Thank you. But anyway, this is a real problem. They had an authentication issue where people couldn't authenticate. What had happened? Somebody pushed a code change into production, and it caused Forrester and other enterprises to lose connection to their apps. People had to work on their local version of documents, a local version of different things that couldn't connect to email. It was a big headache. I mean, I don't know if any planes fell out of the sky or anything, but this is a real problem, and it causes you to lose confidence, right? So let's go to the next slide. And what it all comes down to, right? Performance and scale result in business value, right? So, I mean, Microsoft was able to weather that storm, but not everybody can, right? And if you can't actually think about what customer value is, and you can't actually focus your team on delivering a particular business objective, which is let's increase the customer lifetime value, or let's decrease transaction processing by a certain amount. We talked to an insurance company that their OKR was basically the number of people who use our online mobile app to fill out an insurance claim versus people who do it on paper. They had just launched their mobile app, and the way they judged the success of that app was that every quarter they saw a certain percentage increase in the app versus paper, because they wanted to get rid of those paper claim forms. They're expensive, they're error prone, they can't be corrected on the spot like a mobile app can do, and they caused somebody to have to transcribe it into the system. It was very expensive. And so this insurance company said, let's figure out a way to entice customers to switch over to the mobile app, make that mobile app useful enough and compelling enough that they left the paper ones behind. And that's a very, that's a very practical, pragmatic business OKR. Now, you might say, all right, so what's that got to do with development and performance engineering and whatnot? Well, people aren't going to use that app if it's slow. People aren't going to use that app as if when they need help, they can't ask for it instantly and get it, or do a search and get instantaneous, like, here's how to fill in this form. So performance and scale, the fact that everybody can fill out a claim if they need to, or everybody can use some sort of mobile platform to get healthcare or shop or whatever, those are all important things. And so from a product, like say product owner perspective, so the idea of this pyramid is that, even though you start up with this business concern, instead of maybe measuring all of these constituent roles based on that, base them on how they're contributing to that particular business goal, right? So if you're a product designer or a product owner, maybe you're thinking, well, maybe I can improve the customer experience or the net promoter score or something. Maybe the UI I create can be more compelling, more useful, help people time on target. But if I'm a developer, maybe I can think about, hey, let's get issues fixed earlier so customers aren't waiting for bugs to be fixed, or let's lower the page load time so that the applications are snappier and appear much quicker to be running, so they have more confidence that they're actually doing what they're supposed to be doing. And if you're on the operations team and you're managing a large scale, set of infrastructure, well, you want to make sure that infrastructure is always available to scale up and scale down as necessary. You want to minimize any downtime. You want to minimize disruption. You want a network that scales out with your applications and your servers, right? So you have all these goals to help provide a better customer experience, but you're measuring them in certain metrics that aren't necessarily in business numbers like revenue or market share or customer churn, but they all contribute to it, right? And you might say, well, what's the big deal? Is this just sort of translating? Is this sort of transforming? Do I not have to care about customer churn? I would say no. I would say the goal is there are these OKRs that say, we're on a mission to improve the customer experience and reduce churn. What can we each do? Once we all know what we can each do to do that, it allows us to prioritize the issues that we take on, prioritize the different epics, the different work items, the different kinds of issues that we triage and say, well, this issue that came into the backlog is about something that has nothing to do with customer churn. Let's put that on a lower priority on the back burner and bring in something that we know directly impacts customer churn. So each of these teams can be a little autonomous. They can look at that overall goal, look at what their backlog is, and make decisions based on what do they think will best achieve the goal of reducing customer churn. And they'll have defensible arguments for why they push something off. And it might be that you continuously push those items off because they never rise to the importance of whatever the current new goal is. And that's okay, because over time, what you're going to do is just get rid of those items. There's stuff that you don't work on. There's stuff that you always find low priority, and you just delete it from your backlog eventually because you say, you know what, nobody cares about this. We're not going to do it. Someday, maybe a product owner might say, you know what, let's take all these old ideas that some of them are pretty good and we'll wrap it up into a release. But for right now, they just go forever into the mothball heaven and you don't worry about them. And because this is actually a real problem, believe it or not, where companies hang on to these work items for years. Like, oh, we've got a 2-year backlog. And I'd be like, how can you have a 2-year backlog? And like, well, these things come in and we work on them in a serial way. Some of them are hard and then we have a hot fix. And, by focusing on business objectives, you can eliminate that and you can really focus on what's most important. Next slide, please. Beat that one to death. With more code comes more testing, right? This is a real problem, right? As people have gone from monoliths to microservices, there's this problem where there's multiple streams of code going on, multiple release cycles going on, all of them overlapping each other. So there's unit testing, component testing, functional testing. And the fact of the matter is that now there's dependencies that used to be sort of like built into main memory, like, I'm going to share some information in my monolith between this section and that section. That's not so easy anymore, right? Those are all networked connections via APIs. And so now you have a performance component between each of the things that's running in your ecosystem. Next slide. So what does that mean? That means DevOps teams are taking on more responsibility. And when I mean DevOps, I mean development teams that are owning a lot of the operational capabilities, or I mean operations teams that are acting more like developers, right? Where they're trying to automate all of the things that they used to do manually, or developers who are saying, hey, I need to own a little bit more of the responsibility. This particular model is looking at it from the developer's perspective, right? Where the application development team has to really understand the systems that their software is going to be running on. And the way they do that is they think about operationalizing their role to be more like a product owner, more like a product team, where not only are they releasing that code into an operation mode, they're actually responsible for maintaining that code in operation. And so they need to have tools and facilities that allow them to do that. But along that journey of going from left to right across your screen here, from application to IT platform automation, they also need to understand that they own various responsibilities of doing performance engineering. They own running some performance engineering up front in their unit tests, maybe. They own some performance engineering in the integration test. And then when they get to the final stage, maybe that's when they set up a pre-production system or some other kind of simulation of production where they actually run a load and they have a professional load testing engineer who's maybe got a PhD in performance engineering, really help them fine tune that application. But it's not the first time that that person's seen it. They should have confidence that the development team that's bringing an application to pre-prod or to that performance engineering test system has actually done some thinking about it, has actually put some thought into the process of what is it going to take to create a high performant application. Because what's going to happen, that thing's going to fall flat on that test environment. Your performance test engineer is going to laugh in your face and say, send this thing back to the drawing board. Nobody put any thought into it. So you might say, all right, how do I avoid that scenario? How do I make sure as I'm going through all these various phases of software development that I cover the bases? Well, let's go to the next slide. So performance engineering needs to enter every single phase. That's the answer, right? When you are designing and thinking about a new feature, that's when you should be asking questions. How many people are going to use this feature? How many geographies does this need to run in? How many different countries does this need to run in? And do we have different rules and regulations based on that? Are we in a particular industry where response time has to be within a certain tolerance? Like maybe it's a healthcare monitoring app and it needs to be responsive within, milliseconds or nanoseconds to make sure it's actually picking up on, certain kinds of information. Or if it's operating a car, probably definitely needs to be at least milliseconds to make corrections as it's, as you're pressing on the brake pedal, there's a computer that's trying to figure out the amount of force that goes onto your brake pads. Or as you step on the accelerator, there's a computer that's figuring out how much fuel, how much air, and how do we get it mixed correctly so that the engine can respond quickly, right? That's software that needs to perform. Or if you're writing an application to serve customers in this time of pandemic, you need to realize, you know what? It's not going to be 100,000 users. It's going to be 1 million users. And we need to plan for that because everybody's working from home and they need to use this app. This app could be very handy. And so you need to realize that you're not going to have just, one set of servers running a series of application servers. You're going to have a series of data centers spread out across the country with CDNs, distributed networks, distributed manners for just deploying that software. It's a very complicated problem. But if you don't ask those questions now, you're going to end up going around this circle right back where you started from. The next thing you got to do is you got to model these environments. You have to have a way to simulate this. You need to create some mocks or in some kind of way to actually test your applications very early to say, well, is this API series going to work? Is the payload too big? Are we counting on this to actually work across different geographies, but we really need something in each individual geography? And now that I know what my component looks like, what do the other components look like that I'm going to be working with? What's their response time? Do I have to really plan for the fact that maybe some service is only available, 1 hour a day or something like that? Who knows? And so it's important to understand that and model it. Then you test against those simulations, and then you test against as many actual components as you can get. You monitor the performance and see how it's going. Maybe before you get to monitor performance, you're in this bottom test part of the circle. You say, you know what, maybe we could do some fine tuning. Well, you send it back and you do some tweaking, but you don't send it all the way back and to ask those questions all over again. You just do some fine tuning and then you can get it out the door, monitor, see what's going on, take whatever you're monitoring and bring that back into your simulation and say, well, we know in real life, this is what things do. We have things that break a lot. We have things that go down a lot. All these connections aren't as reliable as we thought they were. And so we have to plan for that. And so you live with the system you have now, but you take that information and you build it into your next design, and you keep trying to iterate and keep trying to improve that. It's not easy to do, but the sooner you start bringing performance engineering into every phase of engineering, the sooner you start to realize that it impacts every single phase of your software development, design, test, and delivery. Next slide. And this gets to the part that your manager or your CTO or your CEO cares about. Maybe it's the CFO. Performance engineering, the sooner you fix it, the less it costs, right? So you have this design phase. You can fix something in hours. You can ask all the right questions and say, you know what? This is going to be working with 15 different components, and it's going to be in not only the United States, but also in Europe. That means we probably need 2 versions because we have to host data in the United States and we have to have data hosted in Europe. And that means we need a design that can accommodate that. This is going to be an application that we think is going to scale. and it's going to scale across, multiple time zones. Maybe what we need to think about is the fact that this application, when it's running on the West Coast, really should be bouncing off local services rather than one central service like in New York. And so those kinds of things can be figured out in the design phase when you're asking the product owner and the business stakeholders, what's really going to happen with this thing? In the build phase, you might go in there and say, oh, you know what? We built this thing. It looks like this API is not going to work very well. Let's take it back, think about it, do it again. When you get to the test phase, that's where you start having a lot more work to rework, right? You've got it to a certain point where you think, I think this is going to be okay. If you've been doing this all along, the test phase is no big deal. If this is the first time you've done performance engineering and you hit the test phase, it's going to be weeks. If it's the first time in the build phase, it's going to be days. And then if you get to production and you haven't done anything with your software and you just push it out the door and it falls flat on its face, guess what? You're going to be up every night working, trying to figure out how the hot fix is going to get out the door. How do you take back that fix that didn't work? How you're going to be working on the weekend to save face and bring that particular software back into production. You're going to have angry customers. You're going to have people who just don't have faith in you anymore. You're going to have angry managers, angry shareholders. And so waiting to production phase to do performance engineering is really just asking for trouble, especially in this day and age where digital experiences are so important. So I'm going to tell you a little story. Next slide, please. Here's my Office 365 performance engineering story. I promised it, I think, on LinkedIn that I would tell some stories of the good old days. But anyways, most people don't realize this, but Office 365, when you look at it, is just a web UI. It was originally written as an ASPX web monolithic web application, it needed to communicate with three low-level APIs. There was SharePoint, Link, and Exchange, plus a few other services it needed to work with. Three is not doing it justice. There was a massive number of people all going at the same time. So when we started writing that web UI, we didn't really know what the API was going to be for those other services. It wasn't like we had some central enterprise architect saying, this shall be the API. It was basically the web UI guy saying, I think that to create a user experience, it's going to look like this. And we just sort of like aimed at a goal of how do you sign somebody up? How do you manage a license? How do you do all this? So my job was to create the mocks for all these APIs that were going to support that UI. And I just basically talked to those teams and said, what do you think you're going to be providing us? And I made it up. So basically, we tested our software on top of these mocks. Then we would create a simulated load. And then at each iteration, we would look at what our constituent partner teams created. And we would try to bring that closer and closer to real life, where every single month we would edit these mocks. We would continue to do performance engineering to make sure that, first of all, we had testable UIs, but second of all, that the APIs were actually going to work, they were going to provide the data we wanted. And then we would count up the number of fetches, count up the number of different network bounces it took when we would test these things on different systems in different parts of the country. And we kind of came up with some really interesting things over this 8 months of development where we were kind of making up the APIs we went along. Eventually, we had the real API. And what we found out was we had too many API calls to complete a single transaction to actually match the target page load time. When we initially designed the application and our partners told us it was going to be 3 or 4 API calls to provision an account and set up an Exchange account and set up a Link account and set up a SharePoint account, they thought that we were going to make all those API calls off of one web page. And what we explained to them was we can't do that because if any of those calls fails, the person signing up will be partially provisioned, not completely provisioned, and they won't be able to go back and do it over again because their account will be taken. And so we found that, though, at the beginning when we started doing this testing and design phase, not at the end when we pushed the code. We found out that we weren't able to debug the API calls. So from a resilience point of view, we realized that there was an API call coming in at the top on the HTTP side, but it went through so many layers. We had no idea when a failure would come back, which layer was actually generating it, or which we were doing all this alignment of basically timestamps, and we realized we needed a correlation ID. So we started inserting an ID that followed that transaction, that request, all the way from when the user first entered it, all the way down to the system of record and back up again. So now we could actually see what's going on. We could trace the API. We could actually understand what was going on and realize, oh, we need to do a better job on that. We found out that services need to be co-located. And then another really interesting thing was to realize that we were doing like, 50 fetches for one web page load because all the different icons and all the images were all being fetched independently. We decided to consolidate that into a single image and host that on a CDN, push it out. We also found out, not here as well, is that if you didn't version your JavaScript, or you didn't version certain things, that it wouldn't update on the user's web browser. They wouldn't notice, or the browser wouldn't actually fetch the latest code from the CDN. So there's all these things that we learned iteratively, but we did it in the test environment. We didn't learn it in production. And thank God we didn't, because it would have been a complete mess had we done that. We would have been, never forgiven, basically. And so this is a really complex scenario where you've got different business divisions all working towards a common goal, but the common goal wasn't defined ahead of time. All we knew was that we had outcomes, performance goals, we had usability goals. And so it really comes down to us all thinking like product teams, thinking about what do I need to do to deliver the best experience, and then cooperating with these teams and figuring it out. So this brings me to this part. Product-led teams think holistically about software, right? When you are in silos and you're thinking about your development team and your little checklist of, I'm going to go through all these story points, and when I'm all done, I'm done. Well, the problem with that approach, or you're an executive and you just push down something and you don't really know how it gets executed, or customers are asking for something and it never gets incorporated into the product plan, right? All of these things can happen because there's some people that manage issues, there's some people that manage products, there's some people that have big portfolio initiatives. There's all these things going on, but they're not really connected together. And so what Forrester's noticed, that the companies that are really being able to transform and really move ahead and really get their DevOps juices flowing are the ones that think like product teams. They think about the fact that we're going to work on a feature or a product, we're going to get it out the door, and we're responsible for its performance. We're responsible for making sure it's a good customer experience. We're responsible for making sure that when it goes to production and it falls flat on its face, we're the ones that are going to be up at night, not some operations guy, not some customer incident specialist who's going to deal with all those sad people because the application keeps falling over. They're going to be calling Chris Condo on his cell phone saying, dude, your software sucks, get online and fix it. And when you understand that, and when you have that kind of mindset, you think from the beginning, like, I don't want to be up at night. I'm going to try to do everything I can to take every step possible to work performance engineering into my application. So when it gets to the finish line, it doesn't fall over on its face. Maybe it falls over, but maybe it'll fall over gracefully, or it gets out to production and it works as expected, but maybe it needs a few tweaks that I can fix. It's not just a complete unmitigated disaster. And that's the whole goal, right? The idea is to try to really fix and uncover issues as early as you can. It's the same thing for every single really domain, I think, in DevOps, is that the earlier you can tackle these problems, the better the fix can be. It's not just the earlier or the lower cost it can be, the better the fix is, right? If you can design in performance versus slap it on later. I mean, how many companies do you know? How many people do you know that just say, oh, well, when we see a performance problem, we just scale up our EC clusters, our EC2 clusters. Well, that's great if you don't mind bleeding money. Wouldn't it be great if your application could get out onto your AWS cluster and run on the smallest AMI or the smallest EC cluster if it didn't need high performance computing to transact one sale? Wouldn't it be great if you could actually scale up and scale down within the same virtual machine with a bunch of containers rather than one big fat container that takes up the whole entire server? And so performance engineering is really important because it helps you maintain costs, maintain performance, maintain customer experience. It's just so critical to everything that you do. So in summary, next slide, performance engineering is a key capability needed to deliver value to customers. That's just true. If you don't accept that, then you're going to go out of business. That's all I'm going to say. Incorporating performance into every phase allows performance to be designed into products from the start versus corrected at the end. So I guess I kind of already foreshadowed this. And shifting to a product focus helps teams understand the importance of performance on customer experience, right? The idea that your customer sees your product as a product or as a service. They don't see it as an epic. They don't see it as a journey. They don't see it as a work item. They don't see it as an API call or a function or a Lambda or even like a search widget. They see it as a product that delivers a service to them. And when you think about it that way, you realize that they're counting on you to deliver that service in a very performant manner, in a very snappy manner, and one that gives them great confidence that you've done everything you can to give them the best experience possible. And when you haven't done that, you've broken their trust and they're going to look elsewhere. Anyways, that's my discussion on performance engineering. Thank you, Vera, for having me here today. And thank you, Neotis. This has been great.
That's awesome. Thank you so much, Chris. I appreciate it. We have a ton of questions that have come in. So many I've been trying to figure out. So again, I'll give you guys the instructions on how to do that. If you're in the session right now, there is a tab and sorry, I keep on looking over here because I have two screens going on. So there is a tab called Q&A. And in there, there's a plus sign at the bottom of the screen that you can click on and submit your question. And so, yes, so what I'll do is you can actually like a question. And so what I'll start with, Chris, is
Yep.
I'll start with the most voted questions.
Okay.
So now you talked about this a little bit in your presentation, but given that there's so many likes, it sounds like maybe we could elaborate a little bit more on it. And
Sure.
It's where does performance testing and DevOps intersect?
Yeah, it's a great question, right? So the way I look at it is the DevOps piece is all about automation. And so if you can do performance, so if you create, let's say, a function in an API, you should have some sort of idea of what performance engineering or what the performance of that application should be. So even if you're not measuring, like, say, milliseconds of transaction time or whatever, or the amount of memory, it's important to start understanding when you're first building and designing your code, what you think those performance characteristics should be. So it's entirely possible that you could create an application the very first time, run it, and then put a meter on it, right? How much memory is it using? How many disk fetches is it doing? Or how much S3 calls is it making? What does the payload look like? Is that payload, fat or is it skinny? All those sorts of things can be looked at from the very beginning. As you get further and further, what you want to do on your performance engineering is, I would say, taking more of a step back, where if there's one component you're testing, all right, well, you're testing very simplistic things. But if you're in the next phase of testing and you've got, like, say, 5 or 6 different applications that are working together in an ecosystem, like, say, a microservices thing, maybe you want to test them from the outside in, right? Well, if what is the overall, say, API that's going to be delivered to a mobile app might rely on 4 different microservices. Let's test that API and then measure the distances and the deltas between each of those teams on the performance side of, response time. How many are the APIs correct? So to me, like, I guess I would like to inject performance engineering, some aspect of it, almost in every phase of DevOps, all the way out the door, where at the end you're measuring and saying, is this what we expected? Is it actually doing what we thought it was going to do? And DevOps is, about automation, right? So the idea that, let's say you do a Jenkins build, it builds your code, it runs your unit test, and then it deploys it to some test machine. Maybe there's like another thing that kicks off and says, all right, now that we've deployed this container to a machine, can we run some sort of dummy test and then put a meter on it and monitor its performance to say, is this, like, look okay, or is it not okay? And even if you don't know what it is, capture the number and then see what it looks like at the next phase. Did it change? Did it not change? Because if you're not measuring and you're not really gaining insight as to how is this application transforming as it goes from the early phase to the later phases, you might find that as you, like, maybe link it with some other modules, and maybe it gets linked into some big open source project, that maybe that open source project, you're using 10% of it. And then for some reason, the other 90% of that project, is consuming a bunch of memory as a binary that you never intended to. So maybe you think, all right, well, maybe that open source project isn't the right one for me because it's taking up a lot more space than I expected it to. and I'm not even using it all. Maybe there's a way I can carve out some of that functionality, just use that small piece and not that whole big chunk. So I kind of feel like, I realize it's kind of like anal to say you want to have, this performance engineering aspect at every phase. But I feel like it's the same for security. It's the same for performance. It's the same for a lot of these things. You really want to just put a scope on these things and find out where does it live and how are we doing? And eventually you want these performance rigs to be set up so that everyone's code goes through a performance test. It's not just certain people's code or certain applications, like everything goes through it. It goes on this environment. This is our performance environment, test it, and have it do it automatically so that everyone has to meet certain numbers, certain threshold. And if they don't have to meet certain numbers, at least they know what they are. And they can look at them in production and say, you know what, in production, I didn't think this was going to be a problem, but it is a problem. There's too much memory, fetches are too long, there's too much wait time. I didn't think it was going to be a problem based on what I saw in the test environment, but it turns out it really is. Now I know how to go back and fix it. And in the test environment, I should see those numbers go down to know that they're going to go down in production. If you don't know what they are in test, how do you know what they're going to be in production?
Very good point. Very, very good point. So, okay, so the next question here, it says, so how do we encourage our teams to consider performance upfront to limit rework later?
Yeah, so I would say that it comes down to people understanding the cost of not doing it, right? There's a certain headache that comes from stuff getting to the very finish line, right? It's almost ready to go out the door. A performance engineer runs a test on it and says, this thing is utterly terrible. Take it back, figure out a way to reduce the number of API calls, figure out a way to reduce the CPU utilization, whatever they come back and tell you, right? And so the problem is that becomes like a hidden cost. People don't actually understand that there's this cost going on, that there's this rework happening, or that your best engineer, she just got taken off some project she was doing because she understands performance engineering and nobody else in your team seems to understand it. And so now she's in charge of shepherding this thing back through its hot fix phase, and she's going to be up all night. And she's going to hate everybody on Monday, but maybe she makes a few changes that makes it work. And like the reality is that's very expensive. It ruins your employee experience. It makes that woman want to say, you know what, this place sucks. I'm going to go someplace else that does engineering right. And so it has a lot of downstream negative impact. So what I would say is start recording all of the steps. I have this other research I do on value stream management. The most important thing that comes from value stream management is that you're actually recording all the time it takes and you're tracking artifacts through your whole process. You say, all right, this application went from design to test, it took a week. It went from test into pre-prod, it took a week. Then it went back to design for a week. It went back to development, and then it went back again, it went back again, went back again, and finally it was ready to go out the door. And it still isn't that great. If you can manage to track all that and say, had we just done this design phase up front and thought about what our performance numbers should be, and then we tested it in our integration test system and then in our pre-prod system, it would have been like sort of like a single motion rather than this iterative flywheel motion of just knee-jerk reaction to bad behavior. And you can calculate the cost in time to market. You can calculate the cost in number of resources spent trying to shepherd that bad design out the door. And you can really, then say, but we've done this other side project where we actually did performance thinking up front. And guess what? We designed something really scalable. We didn't like gold plate it and say, this thing's going to scale to 1 billion users. We just thought about what would our average load be and how can we make sure we hit that? And we tested it and tested it. When it got to production, we saw some numbers we didn't like, but because we had been capturing those numbers in our pre-prod, in our integration, in our dev test environment, the developer could take action, see the changes in unit testing and then functional testing and then pre-prod, and have confidence that when it went to production the next time, it was actually going to be better than it was the first time. Because there's nothing worse than throwing darts at the board at a bad design, right? You throw that thing out the door, it sucks. And now someone's like, make it work. You're like, I think this might help. And you throw a dart and it misses. Like, maybe this will work. And you throw another dart and it misses again. And then suddenly everyone just loses confidence in your ability as an engineer. And you start wondering, what am I doing here? And so to me, showing those two examples and explaining the costs, because managers love money, is the way to actually do it, right? Your manager's manager wants to know, how are you making this company money? They don't care about work items. They don't care about function points. They don't care about any of that crap.
That is for sure. That is for sure. All right.
Just
What
ask
about
Vera. She's always trying to push us,
that's me. I'm a pusher. What should be the performance test strategy as an application transitions from monolithic to microservices based?
It's a great question, right? So in a monolith, a lot of the components can share data via memory, and that's just going to go away. And so you have to recognize that as you break off different pieces of your monolith into services, that there's now an API, there's like an air gap between them. And you have to understand, what is the flow of control? How are these systems codependent on each other? And you have to ask yourself a couple of questions. If one of these services goes down, what does that mean? It probably means the whole thing's fried. That's why you see a lot of people have multiple replicas of different services, and they use like a service mesh to manage that thing, because they can't count on a single application always being alive. And so that's why you see these strategies in microservices that say, we know something's going to go down, just expect it. Do that whole chaos engineering aspect where you know something is going to break. You know you're in an environment where the connection isn't going to be known. And so plan for failure, build it into your product, and start just saying, all right, this particular service is going to go down. How do we make sure it's more resilient? Then when you get to that kind of scale and you start measuring, so there's the performance between the components, there's the expectation that different components won't be able to connect to each other. And so they need to have like a retry, or they need to have a graceful failover, or some way to reverse a transaction that maybe is in progress so that something bad doesn't get recorded or half recorded. Once you figure that out, the next thing you have to figure out is, how does this going to scale? Where are these people going to be? Do these microservices need to run in different geographies? Do they need to be co-located? And then separate replicas of those co-locations need to be in separate parts of the country. All of that stuff's important too. And then how does that play with a CDN? Because a CDN is part of performance engineering as well. Getting all that static content as close to your users as possible. There's a lot of things that need to be taken into consideration. But if you start doing it now at the design phase, you can at least understand the right steps to take when you find that your first impression or your first idea didn't quite work. At least you have something to fall back on and say, all right, but our goal was this, so we can move forward towards that. If you're just breaking something up with like a detonator and saying, let's make some microservices, and then it's all going to work, you're asking for trouble.
Awesome. All right, one more question before we go over to the interactive chat break. And that is, let's see here.
Pick a good one.
So many to choose from. So many to choose from. Let's see. Performance test scripts work better on stable environment. I think you already talked about this a little bit. How does that fit into the CI/CD?
Yeah, that's true, right? They do fit in. That's why when you do performance scripts for very small components, just have very small expectations. Have very small scripts like, what's the memory? What are all the different like utilizations, the life sign numbers, and what's the size of the API calls and things like that, and say, all right, at least I know what the numbers are. Because I'm not maybe measuring in CI/CD for high performance. I'm just trying to get a baseline. What's my baseline for my app? Because when it goes to production and I find out it's too slow, I know that my baseline might need to change. And that's the important part. It's not that you're solving performance in CI/CD. It's that you're creating a baseline of data that then bridges to the next development environment or the next test environment, and then to the next test environment, so that you understand where do I need to move the needle to make an improvement? Because if the problem is that you get out to production on your cloud or your data center, and all of that stuff just takes up too much memory, well, the problem is maybe that open source component that developer downloaded to do one function out of the 100 that are available, maybe that person shouldn't have used that component because it's too fat, and they got lazy and found something that could do something off the shelf that they could have written in like maybe a day. And so have that person write that application, think about shrinking that down, right? So there's a lot of things. If you don't know the baseline, it's very hard to move the needle from the development point of view, because all you know is at the end, everything's too fat, but you don't know why it's too fat. And so there's too many variables. And so the more that you can learn about your internal code and the more that you can learn about your internal processes, as you carry that forward, you can decide, is this where it needs to change or not? And then you have information, you have data, and you can make intelligent decisions based on that. When all you have is at the end, the thing fell over, all you have is panic.
Awesome. Well, thanks, Chris. Great session. Have gotten great feedback so far. So thank you for joining us today. We are going to move this conversation over to the interactive chat break. So for everyone, what you'll need to do is you just go to your tab, your On Now tab, and what you'll see is you'll see the next session that is live. And so, Chris, I will join you over there. So thank you.
Awesome,
everyone.
Vera. Thanks very much. Thanks, Eunice. Thanks, everybody, for tuning in. This was a lot of fun. Thank you.
A lot of fun. Thank you.
Bye-bye.
Bye.